All right, part 2, because my alarm just went off. Sorry about that. So now we're going to find the area of the triangle. And this is to make our trapezoid. I'm showing you one method, which is to break it apart into a rectangle and a triangle. And then I'll show you the other method. We know the formula for a triangle is 1/2 base times height. So that means 1/2. Now the base here is 6. And the height is 8. I would prefer to take half of 8, which is 4. 4 times 6 is 24. But again, students can do it any way that they choose. They do just have to make sure that they write the units. So this is one method of solving this trapezoid problem. Alrighty, now I prefer using the formula. So I'm going to show you that next, and then we'll look at another trapezoid and then a kite. So here is our trapezoid. The formula for a trapezoid is 1/2 base 1 plus base 2 times the height. Okay, so looking at that, let me see if I can get enough room to show. I can't. Anyway, we keep the 1/2. Our base 1, if we look up here, I'm going to use is 12. Plus, our base 2 is going to be this whole thing, which is the 18, times the height, and the height is this 8. Now, one of the problems students are having is they're forgetting PEMDAS, order of operations. You have to do the parentheses first. So 1/2, and we're going to do 12 plus 18, which is 30, times 8. Now, we can take a half of these. I'm going to take, oh, it really doesn't matter. I'm just going to work this one out first. I'm going to do 3 times 8, which is 24, and stick a 0 on it. And then half of that would be 120, and we used meters, so meters squared. Okay. Oh, and I'm sorry, I forgot over here. When we do this, we have the rectangle and the triangle, but we also have to add that together. So if we take the 96 plus 24, we get 10, carry our 1, 10 plus 2 is 120 meters squared. And you can see both of these methods give us the same answer. Okay, so trapezoids you can figure as triangles and rectangles. Sometimes it'll have one triangle, sometimes it'll have 2 triangles, plus 1 rectangle. Or you can use the formula, which is the method that I prefer. But I show kids both ways in class. All right, now let me show you one more because some of these cause some difficulties and I want to make sure that I've shown you everything that I can. So if we have a figure such as, well, the numbers aren't going to look like this, but anyway, this is close. This length is 7. This is 4. They tell us this guy is 3. And this one is 2. Alrighty. Now, this has, if you chose to break it into, and actually this comes over a little bit farther. Let me see if I can fix this a little bit more. It comes more like this. There you go. This does have 2 triangles, even though they don't show it to you like that. So you have to be careful. Some of the students are not realizing that. They're just taking what's in the book and assuming they gave all the information, which isn't the case. This does have 2 triangles and 1 rectangle. And then this, if you were to figure it out, would actually, since this is 2, this is 4, that's 6, that means this guy would only be 1. And a lot of students would have repeated the 2 there. So just be careful with that. I am going to show you using the formula. So 1/2 base 1 plus base 2 times the height. Another thing the students are struggling with is they're thinking these are the bases, which is not correct. Even though our figure is turned this way, this is parallel to this side. That is what makes our bases. Or turn your paper. As I told them, I spin it. I wouldn't see it otherwise. And now I can see there's a base and there's a base. Okay, so my bases are going to be the 7 and the 4. So 7 plus 4. And then my height is going to be this guy or him, and that's going to be 3. Again, work out the 7 plus 4 first, which is 11 times 3. So that's going to be 33 divided by 2. And again, you can do the division. So 2 goes into 33 once, 1 left over, bring down that 3. And 2 goes into 13 6 times, which is 12. And when we add the decimal and the 0, we're going to have 16.5. And this one, since I didn't write what units it is, you could also write units squared. And that is a trapezoid. Next, we're going to look at a rhombus. The rhombus has a very nice formula, but again, students are struggling turning their page and finding the rhombus. So when you do a rhombus, let me see if I can draw this. It looks something like this. And what we looked at is the fact that this, when you cut it in half, I've encouraged students to cut it in half and find the 2 triangles that are identical to each other. So this one is identical to this. It is just flipped over that line of symmetry. This is the triangle we're going to be looking at. Now, because we have 2 triangles, 2 times the area of a triangle, 1/2 base times height, we discovered that those just cross out, and we're going to be left with area equals base times height. All right, must be careful to only use the height up here. We're not using both of them. This will be your base, and this will be your height. So in this case, I have my height is 6, and I have this side is 8 feet, and this side is 9 feet. Okay. So I'm going to take 8 plus 9, which is 17, times my height of 6, and when I do that, I'll get 102 feet squared. So it's a pretty easy formula. If you think of the 2 triangles being cut in half, they need to be the same type of triangle, both top and bottom. They should be a mirror image of each other. And so 2 triangles, and then when you look at it, it's really getting rid of the half, and you're just left with base times height. For those of you that remember this from your schooling, the formula that I had learned was 1/2 diagonal 1 times diagonal 2. What they're showing you in that is it is really the diagonals are really going to be, this is one of them, and this is the other one. And if you do that, it's still going to work out the same. For instance, this would be a 6 down here. And so 8 plus 9 was the 17 and 1/2. And then 6 plus 6 is 12. I'm going to cut the 12 in half, which is 6. So 6 times 17 goes right back to 102 feet squared. So both ways worked exactly the same. Some of the notes that we took on this are here. We talked about breaking the trapezoid into a rectangle and triangles. Here was working with the rectangle and the triangle, 2 of them. This one I showed breaking up the two triangles, and so two triangles and the rectangle, where this one I did using the formula. So we did do both, and I told students I don't mind which they choose, they just need to do the one that they prefer. And then our kites. We talked about breaking into two triangles. So here you can see I left the formula without, but it becomes still base times height. If you choose to use the diagonal formula and you're not using both sides, not the 10, but instead you just use the 5, then you're going to need to cut it in half. And here's another one. And we talked about how it's not this triangle and this triangle. Instead, it's this triangle and this triangle. There's one last piece that we will be testing on. Well, actually 2 more pieces. We talked about some of these different shapes, and I encourage the students to use different colors to shade, for instance, the rectangle and the triangle. Here we had a trapezoid, and then we had to subtract out a rectangle. Here we had a rectangle and a trapezoid, although some took this as a rectangle, and a triangle, whichever is fine. It doesn't matter. They're all going to work out the same. We introduced then at the end nets. So we talked about faces, which are colored in purple. It's what faces you. We talked about bases. Bases are always the top and bottom. So this is the orange part here. Or in a pyramid, it's only one side, because it has a point. The point being called your vertices or vertex, and the edges are where the faces come together. Then we looked at prisms. This is an instance of a rectangular prism. Prisms always have 2 bases. So this is a prism because it has 2 bases. Then you look at the shape of the base, which I encourage students to highlight, and it is a rectangle, so this is called a rectangular prism. Over here, there is just one base, which means it is a pyramid, and the shape of that base is a triangle, so it's a triangular pyramid. This one has 2 bases, so it's called a prism. And the shape of those bases are triangles, so it's a triangular prism. Where this one down here only has 1 base, because it has 1 base, it's a pyramid. And because it is a square, the base is a square, then you have a square pyramid. We did talk about their nets. And one of the things that helps is, again, to color the bases. So for instance, today, we looked at these guys. So when you color in the base, if there's only one, it must be a pyramid. And every pyramid has triangular faces. So this has triangular faces. The base, there's only one, and it is in the shape of a triangle, so it's a triangular pyramid. Where this guy still only has 1 base, has triangle faces, so it is a pyramid, but the base is a square, so a square pyramid. These 2 are examples of rectangular prisms. Again, you can only have 2 bases. We began assembling this in class so that they could see different nets. This has 2 bases, so it must be a prism. 2 bases, so it is a prism. 2 bases, so it is a prism. 1 base and 1 base, so a pyramid. And then you name it according to the shape of the base. So these are going to be rectangular prisms, where this one is a triangular prism. These 2 only have one base, so they are pyramids. This is a square, so a square pyramid, where this one's a triangle, so a triangular pyramid. And that should be it. Hope that helps.